video is on evolutionary algorithms, and then the very first thing I want to talk about within this is exactly why I want to talk about algorithms, and then in this instance, evolutionary algorithms, as opposed to like just LLM models and utilizing just like LLMs overall. Like, why not just utilize an LLM for this? Because an LLM could handle a lot of these tasks, right? But the thing is like in the real world, when you think about these things beyond like the engineer standpoint, especially as and the researcher standpoint, especially as like a CFO, CEO along those lines, very first thing that you want to know is like the cost of everything, right? And then so while you can utilize LM models for a lot of things, the costs become really prohibitive when you get into like real world examples. And then so within that, I always look for like what's the actual use case, and then you don't have to throw like a hammer, like a jackhammer at every single use case, right? Not every single use case requires like that level of complexity and that level of computation. And like, so the big thing is that I want to showcase with this is that all of this is running just based off of CPU. So you don't need any GPU whatsoever. And it doesn't utilize like really any RAM, like any more RAM than your standard application, right? Within these evolutionary algorithms. So why would you run an evolutionary algorithm over an LLM model? Because even like, so if you could set this up within an LLM model, you'd have to train it first, fine tune it, and then there's different elements, right? And we're talking in this instance evolutionary algorithms overall, which would be kind of harder for an LLM model to simulate, but it would still be possible. But you're talking about like complex cost and time and overall, right, and resources, whereas we can just run this algorithm in CPU in Google Colab in this instance, and we have no issues. And then so that's kind of the why, right? And then so I guess the second thing to dive into is overall what exactly are evolutionary algorithms overall, and like they're exactly what they sound like, right? So evolutionary algorithms, they're based off of the biological concept of evolution, right? Of like genetic evolution, and then so in that instance you have populations of the algorithms, and then the populations have different generations, and then so in this instance you can set the generations like 50 generations or 100 generations, and then the algorithm will essentially produce like random like mutations on the population over time, and then you can adjust essentially the randomness of that, and then you can also adjust, say you want like in this instance, in a lot of these instances, there'll be like you'll see that there'll be like elites within the population, and then elites would be traits that you want to carry over from like one genetic mutation or one genetic generation to the other, and then that's really all that genetic algorithms are, right? Is based off of that concept, but based off of that concept, you can apply that concept to other things, and then so other business type of use cases, and then so that's what I really want to highlight with this video today. And then so again, like the big thing that you can see is that like these algorithms, like they run right away, right? So if I run this and then we're starting it, it's we can see that it's like instantaneous that it ran, right? It just executed again, and then just how quick that is. And then so with all these examples, that's kind of like number one is just how quick overall they run, no resources used overall. And then this first one that we're running is just real simple, right? It's just I'm giving it essentially at the top here this mathematical equation to find this function, and then I'm asking it to optimize, try to optimize to this function, and it's running for 50 generations. With a genetic population of 100 per generation. And then so within this, it essentially selects the best individuals, and then it goes for best fitness score is what it's trying to go for within these generations. And then so it's optimizing this binary code, right? Like ones and zeros. And then coming through, we get the final solution, and then the best result overall. The final solution is like what it's printing out there, but you can see it prints out like all different variations of the binary code each generation, right? And it's just randomized mutations of like different generations and of this instance of um, these evolutionary algorithms, right? And so this is kind of just like showing you and showcasing like the most like basic instance, like trying to solve for a function within these, and what the algorithms do. And this is again over 50 generations uh, that it'll do this just for binary code. And then so kind of like diving into more real world examples, I have two. And then so the first one would be for like inventory management, right? And then so with inventory management, this is plugging in the equations of that you have demand patterns, shortage costs, your holding costs, your period of time that you want to hold the product for, and your number of products. So you have kind of like all these dimensions and variables that can go in. And then when you have like lots of different variables like this, and then it's over time and lots of different outcomes based off of these types of things, this is where evolutionary algorithms come in and are really good, right? So uh, inventory management problems where you have and you want to balance and equate for like demand versus holding costs, etc. And then so that's what we're doing here. And then so we just run through, and it's a lot of code. And then so this is more complicated code, right? Because we're giving it all of these variables, and then we can adjust here the number of products, number of periods. There's lots of things that we can adjust within this code too. Number of generations, and then this one's running for 100 generations. And then with this, I output also kind of the end results, right? So you can see, and then what the goal of this is to give you the best. Let's say that in a real world corporate instance, you have like inventory, and then you want to maximize not having inventory on the shelf, but having inventory available for customers. And that's exactly what this is, right? And then so it's maximizing your cost within that, assuming that time on the shelf also contributes to your cost. So if you buy a widget for $5 and then it sits on the shelf for a week, let's say that widget is then the holding cost of that then is like the total cost of that widget then is $10 because the holding cost of $5 and the initial purchase price of $5, and then so 2 weeks it would be 15, etc., right, 20, etc. And then so you would want to make it so that you're selling it instantaneously, but then you also on the other end you put a negative price for not having, or a negative for not having it in stock, right? So you want to make sure that you balance that, and then you also have it in stock, and then within that, this genetic algorithm will essentially tell you based off of the different variables that you put in with differing levels of accuracy based off of those variables and the data of those variables, exactly what your inventory levels should be over time. And then it will give you like different generational examples in this instance when we're looking at evolutionary algorithms. And then so the next kind of like real world example that I have here is this is I thought it was a pretty cool example of essentially the cost of burgers are the price of burgers versus the demand for people buying the burgers. And then so this is just essentially simulating that, and then it's essentially, if you look through the code, it's assuming that our cost for burgers for each burger is $2, and then we want to know like what's the like our maximum profit that we should like what's our like what's the price that we should be selling our burgers at to maximize profits overall, and then profit versus demand, right? And then so we go through and then we run our equation and we give it kind of a lot of price points, number of periods, our cost per burger, and then all of our numbers. And then when we do that, what we can see is that like very, very clearly over time we should be setting our burgers at $6 per burger. Like that's the optimum, between $6 and $7. But it's better to go up. So that's what we're gonna like maximize our value. But so in this instance, I would like very clearly be setting our burger cost at $6 in this instance. And then so just using real simple evolutionary algorithms in this instance over time, we like again, it's the accuracy of the predictions are based off of the variables and the data of the variables that you're putting in. So you have to, of course, account for that, but it gives you just really easy overall metrics to follow. And then so again, like utilizing, why would you utilize this over an LLM model? And real world examples again, right? This is a lot cheaper for a corporation to run just overall running this running evolutionary algorithms as opposed to like just trying to like jackhammer it in again, right? Like you want to like tune it in. What's the best tuned solution? And then the best tuned solution in this instance would be evolutionary algorithms. And then so I guess the last thing to note and to leave this video on in that instance is what is this instance, right? And then so very clearly we're looking at kind of like demand curves over time, and then where there's again multiple variables, and then where we want to essentially like look at essentially like a few factors within those variables. So in this instance, in our burger example, we want to look at like price versus demand, and then in our example of our inventory, we want to look at inventory cost versus hold time. And then so, but then we want to be able to plug in like a lot of different variables for like the different generations to be able to generate data off of based off of those, right? And then so that's kind of what this instance is in that instance. So if you want like let's say like function calling, or like what's the capital of California, like running like facts or factual information, natural language processing, things like that. Evolutionary algorithms aren't really good for that, but for like demand over time, for a lot of things that the corporations generally are looking for, evolutionary algorithms are going to be a lot better bet and a lot bigger bet overall than LLM models overall. And then so that's kind of why I want to make this video to introduce anyone interested overall in these concepts like machine learning and AI concepts to definitely check out evolutionary algorithms. So hope you enjoyed this video, and if you like this type of content, please like and subscribe. Thank you very much.